Okay, this is video quiz part number 2. So question 2 for the home video quiz on proportions. During a flu vaccine shortage in the United States, it was believed that 45% of the vaccine eligible people received the flu vaccine. So we have this belief of 45%. The result of a survey given to a random sample, and oh, nice for them to tell me that, that's always important, 2,350 vaccine eligible people indicated that 978 of the 2,350 had received the flu vaccine. So we have a sample of 2,350 that received it. Construct a 99% confidence interval for the proportion of vaccine eligible people who had received flu vaccine. Give an interpretation of your confidence interval and the confidence level. So here we say we have to do our confidence interval and the confidence level. So we have to do both. So make sure that we address the confidence level as well. Use your confidence interval to comment on the belief that 45% of the vaccine eligible people had received the flu vaccine. So in this case, I have to comment whether or not 45% receive it. And I also have to create the interval and go over the confidence level. So the very first thing we do is define the parameter. So the very first thing we have to do is define the parameter. So let P equal the true population proportion of vaccine eligible people who received the vaccine. All right, I'm going to go ahead and write down our initial equation. And our initial equation is P hat plus or minus Z star, and then P hat Q hat in Q hat equals 1 minus P. If you use the Q hat notation, you need to say what it is. If you choose not to write that, you can actually do this instead. It's perfectly 100% acceptable. P hat plus or minus Z star P hat times 1 minus P hat over N. When you're working with confidence levels, make sure you have the hats. It's really, really important not to have the hats because the P hat is the sample proportion. And P is the population proportion. And this is just as important as talking about X bar and mu, X bar being the sample mean, M being the population. So once again, you always need to make sure you do this correctly. And notice, this must be a P. This cannot be a P hat. Must be a P, not a P hat. All right, so our very first condition, well, we need a random sample. And they told us we had a random sample of 2,350 and that was given. All right, it was really nice of them to let us know that it was a random sample was done. N needs to be less than 10% of the population. Our sample size needs to be less than 10% of the population. So 2,350 divided by 0.1. Reasonable to assume that there are at least 23,500 vaccine eligible people in the United States. And we know that it's out of the US. Why? Because the shortage was in the US. We're not talking about the shortage in Texas or San Antonio or Montana for that matter. It's a shortage within the US. So the population of vaccine eligible people, I'm sure, is substantially more than 23,500. Then we need to check our normality condition. Is this sample large enough to use the normal approximation? So in this case, we said that they were 900, and it wasn't 938. This is a typo. This should have been 978. So we had 978 people that were eligible for the vaccine. Well, that's greater than 10, so we're large enough in that sense. Then we need to check the failure. Though 978 who had the vaccine. So this 978 were vaccinated. All right, they'd gotten the vaccine. And then we had the rest who did not get it, which is 2,350 minus 978, or 1,372. Well, that number is also greater than 10. So consequently, the sample is large enough to use the normal approximation. All right, we originally set up our our equation, and one of the things we need to know is p hat, because see, they essentially gave us p. They essentially said, hey, we believe this. This is believing the innocent guy. This would essentially be my null hypothesis. No, this is what we believe. And then they said, but then we don't have for our formula that we have to have is we don't have p hat. Well, p hat equals x over n, with x being the successes and n be the sample size. And so it turns out that our number of successes were the number of people who actually had it were 978 out of 2,350. So 978 out of 2,350 received the vaccine. So that gives me my sample proportion. And when I multiply that out, I get 0.4162, right? So my p hat's 0.4162, and I can start plugging into my equation. Now I'll come back and I'll show you how to get Z star in a moment. So we have 0.4162. So I wrote p hat there, and then I did 1 minus 0.4162. And I know 978 divided by 2,350, and I rounded, okay? And I could have truncated, that's fine. The main thing is when we're plugging things in the calculator, X must be a whole number, N must be a whole number, because that's what the calculator is going to ask you for. All right, so we've plugged in, except we haven't done our Z star. So here's a reminder. Second, vars, inverse norm. And we're wanting to calculate a 99% confidence interval. So parenthesis 1 minus 0.99, close parenthesis, divided by 2. We're calculating a Z, and Z statistics are either 0 or 1, or are the mean of 0 and a standard deviation of 1. I calculate and I get a value of about 2.578. We always use the positive. So 2.576 right here is what I wrote down. That's pretty consistent. All right. And so then I need to calculate my interval. All right. And calculating our interval, so that was where we got our Z star from. Calculating your interval is going to be stat, test, drop down. And we're going to go to 1 proportion Z interval. 1 proportion Z interval. And we had how many successes? Well, we had 978 who had received the vaccine. Then we had how many were there in the total sample? 2,350. And we need a confidence level of 99%, so 0.99. And we end up getting this as our interval. All right. And you can see our p hat, which is what we used over here. So somewhere between, and this is not exactly, but about 39% and about 44%. All right, so 39% to 44% is what we see. And so we always have to do the conclusion every single time, even though they might not specifically ask for it. This is what our conclusion statement looks like. And we are 99% confident that the true population proportion of vaccine eligible people who received the vaccine lies within the interval 39% to 44%. So we believe, are 99% confident that between 39 and 44% received it, okay? Because then they asked, in this case, they asked for us to interpret the confidence level. So I've got to interpret the confidence level. And because 45% does not lie within the 99% confidence interval, oh, excuse me. Actually, you know what? I did not do that. I should have done that. So I am missing a part of this. So we're going to have to write this down. So the part that I'm missing is the confidence, interpreting the confidence level. In repeated sampling. Of course, you can't see that. There we go. In repeated sampling, we are 99% confident I'm sorry, I'm messing things up. In repeated sampling, we expect this method, so the way we did it, to capture the true population proportion of people, which people who have received the vaccine in the US 99% of the time. And by the way, going back and checking your work and finding out you missed something, really important, because that would have been an easy point to have gotten, because I've already done the work. And so basically, since it asked for the confidence level in repeated sampling, we expect this method or our method to capture the true population proportion of people who have received the vaccine in the US 99% of the time. All right. Okay. The next thing it asked us to do was use your confidence interval to comment on the belief that 45% of the vaccine eligible people had received the flu vaccine. It's like, hey, is it reasonable to make that claim? We believe it, but based on your interval, can we support it? Well, let's look at the interval. Here's my interval, and 45% is above it. Now, it's close, but I don't care how close it is. If it's not in there based on our interval, we can't accept it. So what we're going to say is, because 45% does not lie within the 99% confidence interval, we do not believe that 45% of the people in the US received the vaccine. In fact, and we should add this should be added here. It wasn't really intentionally left off, it's just so that I wanted to make an extra point this time. So, in fact, we believe that less than 45% received the vaccine. Because, and this is our why we believe it, because the interval lies below 45%. Because the interval lies below 45%, we actually believe that less than 45% received it, which is sad. It'd been nice if the interval was above it and we say, well, good news, more than 45%. Here we believe less than 45% actually. Suppose a similar survey will be given to vaccine eligible people in Canada by the Canadian health officials. And a 99% confidence interval for the proportion of people who will receive the flu vaccine is to be constructed. What is the smallest sample size that can be used to guarantee a margin of error that will be equal to or less or equal to 0.02? So we're looking for what sample size do we need to have an ME equal to 0.02, right? If we're looking for a margin of error equal to 0.02, now we need to be really careful here. And this is when College Board was actually trying to trick people. A lot of students read that and they go, okay, we can use p hat equal to 0.45, or we can use p is equal to 0.45 as our estimate. And we can't do that. And some people want to use the 0.4162 as an estimate, and we can't do that. And you're like, well, wait a second, that's definitely p hat. Why can't I use one of those two numbers? And the reason is that's supposed to be the proportion of the population. Guess what? This was the proportion of United States versus this being the proportion for Canada. So because Canada's healthcare is not the same as the US, we do not have an estimate for the proportion of people in Canada who received the vaccine and must use 0.50 as opposed to 0.416 or 0.45. We can't use either of these. We're going to have to use 0.50. And remember, we always use 0.50 if we don't have an estimate. So for this particular formula, so for this particular equation, I always start off by writing down the confidence interval formula. Whenever they want to do sample size, I write the confidence interval formula, which is p hat plus or minus z star p hat q hat over n. And I know maybe I'm a little bit stubborn that I do it this way, but I'm just not very good at memorizing that, the other formula. And I have to memorize this anyway, and I have to know that this is equal to the margin of error. All right, so they told us our margin of error is 0.02. So I'm going to rewrite this for just as the margin of error. So I can go ahead and set this up to solve. So margin of error equals z star p hat q hat over n. I'm going to start plugging in. Z star in this case is 0.02. They say I want to no more than 2%. I also need to calculate the Z star, and I can get Z star because they told me they wanted this to be 99%. So the second vars, inverse norm. And I already had 99% in there, so 1 point, well, here I'll do that. Parenthesis 1 minus 0.99, close parenthesis, divided by 2. Because the mean is 0 in this, we always use a mean of 0 and a standard deviation of 1 for z. And we calculate it and we get 2.576. So z star is 2.576. Because we don't have an estimate for p hat, we have to take the worst case scenario, because that gives me the largest margin of error. And that's my worst case. And so that becomes this. At this point, I'm going to divide both sides by 2.576. And this goes away, and I'm just going to multiply at the same time. So now I have 0.02 over 2.576, which equals the square root of 0.25 over n. Well, I know the radical bothers people, and so I'm going to do something that's actually very, very bad mathematical notation, but I'm going to tell you College Board won't mind, and it's just quick and easy. So I just go ahead and say I'm going to square everything. Well, if I do that, this becomes 0.25 over n. The radical is gone. And I'm going to go ahead and take 0.02 divided by 2.56. Press enter. Now I squared everything, so I need to square that. So I'm going to square that, and I get a really, really small number. I'm going to have 4 leading zeros out of here. So this gives me 0.00006, etc. And I'm just going to put it over 1 because it makes my proportion nice and easy. So we know we would be multiplying those two numbers and dividing by the third. So you keeping that ugly number in the calculator, I'm going to go 0.25 divided by that number and press enter. And I end up getting 4147.36. And we never leave it like this. So this is n equals that. That's what we actually calculated mathematically. For sample size, we always are going to round up. So in this case, n equals 4148. So the minimum sample size for Canada would be 4148. All right, 4148. Here's it written out a little nicer if you'd like to see it. All right, so we always need to make sure that we round up to an even whole number. Okay, and notice that's below 0.5, but I still round up because we always round up on this. I'll pause the video before we start the hypothesis test.